Hello friends, welcome to the third video on priority queue. Today we're going to be looking at how to turn a main priority queue into a max priority queue. So the question that might come to your mind is why, right? Why should you learn how to turn a main priority queue into a max priority queue? Well, it turns out that the standard libraries of most programming languages only provide one type of priority queue, and that is majorly the main priority queue. However, sometimes we need a max priority queue, right? So we have to find a way to use a main priority queue as a max priority queue. There are two ways to do this, okay? So let's check out the first way. Now, since the elements in the priority queue are comparable, they implement some sort of comparable interface which we can simply negate to achieve a max priority queue. So what does this mean? Now let x and y be numbers in the priority queue. For a mean priority queue, if x is less than or equal to y, then x comes out of the priority queue before y, right? This is the normal behavior of a mean priority queue. Now, by negating this equality sign, we're going to achieve the opposite of this behavior. So by saying if x is greater than or equal to y, then y will come out of the priority queue before x, which gives us a max priority queue. So let me show you an example. So this is a mean priority queue, and you can also see the comparator here. X is less than or equal to y. So we expect the smallest element to come out first. So the first time I call the poll method, I'm going to get 3 because 3 is the smallest here, right? Then the second time, I'm going to have 4 because 4 is the smallest, okay? So the smallest here now is 5. So if I call the next poll operation, I have 5, right? The smallest element here is 7. So I expect 7, then like that. Okay, so you can see that the comparator is x less than or equal to y, and that was why we achieved this removal in this pattern. So now let us negate this operator, and you will see that it changes to the opposite behavior. So now we have x greater than or equal to y. So this means that the bigger element would come out of the priority queue before the smaller element. So if I call the first poll method, I have 10. Okay, then now I have 8. I have 7, 5, 4, and 3. So you can see that this behaved opposite to what we have before just because we changed the equality sign. So this is the first way to turn a mean priority queue into a max priority queue. So let's look at this. Let's look at the second approach. The second way to do this is to negate the numbers before you insert them into the priority queue, and negate them after they are taken out of the priority queue. Okay, so this is easier, right? But the only limitation is that it is specific to only numbers. Okay, so you can't use this method if the element in each node is a string. Okay, so that is the only limitation that we have here. So let's check out how this works. Okay, so over here you can see that we inserted all these elements in their negative form. Okay, so all the elements are in their negative form. Okay, so now if I call the first poll operation, I'm going to have minus 10. Okay, then I can change that to 10. Okay, then if I go ahead to remove the next element, I have minus 8. Then that changes to 8. Okay, so as I'm removing each element, I am negating the value. Okay, so now I have minus 7, which will change to 7. Then I have minus 5, change to 5. Then minus 4, change to 4, and like that. So you can see that at the end of the day, these elements are arranged from the maximum value to the minimum values, right? So like from the greatest to the smallest, which is how we expect a max priority queue to behave, and this is what we have over here. So this is the second way to turn a min priority queue to a max priority queue. So all the examples that we've been looking at before was using numbers, right? So, but it is possible that the elements in a priority queue should be strings, okay? So how do we turn a min priority queue that contains strings to a max priority queue? Most strings are sorted in a lexicographic order, okay, which is the default order for sorting strings in most programming languages. Now let lex be a comparator that sorts strings in a lexicographic order, okay, and let NLEX be the negation of lex. Okay, so we have two strings s1 and s2 that we want to compare. So for lex, if s1 is less than s2, we have -1. Okay, if s1 is equal to s2, we have 0. If s1 is greater than s2, we have +1. Now, by negating lex, if s1 is less than s2, we are supposed to have -1, right? But we're going to negate it. Okay, then if we have s1 equal to s2, we have 0, right? We should negate that, but that is still the same thing, right? Then if s1 is greater than s2, we should have +1, but we are going to negate it. Okay, so what is this going to cause, right? Like, what is the impact of this? Let's check this out in an example. All right, so let's assume we have a min priority queue where we have all these elements which are strings. Okay, so now we are using the lex comparator. Okay, so we expect the alphabet or the string that is closest and shortest, right, to come out of the priority queue first. So here's what I mean. If you call the first remove operation, we're going to have A, because A happens to be at the beginning of the alphabet in English language, and it is also the shortest string in the priority queue. Okay, then if you call the next remove operation, we have B. Okay, then we have this, we have this, and that. Okay, so this is the way strings are sorted in a lexicographic order. Okay, so now this is using the lex comparator. So if we use the NLEX, what are we going to have? So now we're going to use the NLEX, which is simply the negation of lex. So the first time we remove an element, we're going to have XX, right? Because it's like the string closest to the end of alphabets in English language, right? And it also has 2 characters, right? So now if we call the next remove operation, we have XR, then we have X, then we have FZ, then we have B, and we have A. Okay, and if you check this out, this is the opposite of what we got when we used the lex comparator. Okay, but by using the NLEX, we achieve the opposite. So now if we compare the results that we got for while using each comparator, you will discover that the results are directly opposite, right? So if you check this right, and you check this, you will discover that it is directly opposite. Okay, so this is using the lex and this is using the NLEX. Okay, all right, thanks everyone. Don't forget to subscribe. Please do well to subscribe if you enjoyed the video. If you learned something, please subscribe. And if you have any question, if you have any doubt, or if you have any suggestion, just put it in the comment box. I will definitely respond to that. Okay, thanks, and see you in the next video. Bye.